Let's take a look at simplifying radical expressions, part 2. So one thing we didn't do in the last video was take a look at expressions where we have an arbitrary root, say the k root, of a quotient. And so much like doing exponents across multiplying, doing the index across division works exactly the same. So this would mean the k root of a over the k root of b. Another way of saying that would be the quotient a over b to the 1k power is 1 over k power is to say a to the 1k over b to the 1k. So, I mean, an example of that would be something like taking the number like 27 over 125 and raising that whole thing to the cube root power. I mean, taking the cube root of all of that. That's the same as saying, well, we want to know what the cube root of 27 over the cube root of 125 is, and we know the cube root from previous discussion. We know that the cube root of 27 is 3, and the cube root of 5 is, well, let's see, 125 is 5, that's 25, 5, that's 5, and 5 is 1. So that is the cube root of 5 cubed, which we know that 5 cubed, the cube root of 5 cubed is just 5. So 3 over 5 is our answer. Let's take another look at something like that, just a little bit more involved. So let's try, again, let's do the cubed root of, let's see, 27x to the 5th power over 343 y to the 3rd power. Well, that would be the cubed root of 3 cubed times x cubed times x squared, right? Because x to the 5th, if we reverse our product rule, that's x to the 3rd times x to the 2nd power. And that's going to be over the cubed root of, let's see what 343 is. 343 is 7, goes into 49 times 7, 7 and 7 down to 1. So it's 7 cubed. That's cool. 7 cubed times y cubed. Now let's see who's got the get out of jail free card. Let's see. This tells us what the get out of jail free card is, and the get out of jail free card is 3. So 3 comes out, and x to the 3rd comes out. And here 7 comes out, and the y comes out. Let's see what we're left with. 3x times the cube root of x squared divided by 7y, and that is our answer. Well, that was fun and all, but let's use our powers that we've just acquired to try something much more interesting. This one says divide and simplify the quantity cube root of a squared b to the 4th divided by the square root of ab. Well, here we have again those crazy 2 different indices, and this part isn't even rational, right? When we put a square root in a denominator, that's not even rational. How do we even deal with that? Oh, I remember how we deal with that. First of all, let's turn it all into rational exponents, shall we? That would be a squared b to the 4th power raised to the 1/3 power. That's our cubed root, and we'll take that over a times b, and we'll raise that to the 1/2 power. All right, now we can deal. Now it's time to play our game. So that would be a to the 2/3 power times b to the 4/3 power over a to the 1/2 b to the also 1/2. Well, looky who's got the cookie. I've got a number over itself with different exponents times a number over itself with different exponents. So what do we do with that? What do we do with those exponents? We use the quotient rule, won't we? And we'll say that's equal to the a times raised to the 2/3 minus 1/2 times b raised to the 4/3 minus 1/2. And in order to do the subtraction, we'll need common denominators for our exponents. So 2/3 is going to be the same as 4/6, whilst 1/2 will be the same as 3/6, and 4/3 will be the same as 8/6 minus, again, 3/6. All right, so I've got a to the 4 minus 3 is 1/6, b to the 8 minus 3 is 5/6, and now we can put these under one radical with one index. That will be the 6th root of ab to the 5th power. Hot darn, that was fun.